Hello everyone, I'm David McLeod.
And I'm Marco Espinosa.
And we are mechanical engineering students studying at the University of Houston in our junior year.
Today's video will focus on discussing and exposing a few of the preliminary aspects of the research project we're currently working on.
To help us with this project, our research guides are Dr. Christiana Chang and Dr. Ashutosh Agrawal.
The scope for our project has been shaped around the needs of our client, who is OTW Bat Company, a company based in Houston, Texas.
Our research has two primary objectives. The first being whether or not the impact, if any at all, that resin coating has on professional wooden bats.
More specifically, whether OTW's own resin mix has a positive or negative impact on bat performance.
The second being whether or not the trampoline effect is true.
In efforts to understand if dynamic testing should be a priority in our data collection methods, we decided to test it out firsthand.
In a research dynamic scenario, we understand that certain parameters need to be kept to make the data as reliable as possible. Although this hitting session cannot supply reliable data, it does serve as a demonstration of the stresses that a wooden bat undergoes.
The parameters that we were able to maintain constant were temperature, humidity, the pitch traveling at 90 miles per hour, and using the same 3330 maple bat. The parameter that we were not able to maintain constant is swing speed, although we did average 82 miles per hour over the 269 swings.
After only the 208th swing of using a retail wooden bat, the integrity of the wood was detrimented. This is where OTW claims superiority over other bat manufacturers, from not only a performance standpoint, but also their bat's increased lifespan. The difference is claimed to be OTW's specialized resin coating and bat making process as a whole.
As shown in the pictures, the crack began at the handle and elongated towards the barrel of the bat. By the 247 hit of the bat, it showed a very clear fracture along its wood grain. An application of our findings will be to prevent multi-piece fractures from occurring, therefore reducing chances for injuries during games.
Here we have the wooden bat making process. The wooden billets are stored in a weather-controlled room until selected to be used. The billets are then chosen based on weight and determination of whether the wood grain satisfies the requirements of MLB standards, and the player's preference of grain size is also taken into account.
Moving onwards with our research, we've come to the conclusion that there are 3 tests that we must complete in order to gather the necessary data to fulfill the 2 primary objectives of our research. Primarily, the TrackMan method.
Exactly, and basically what the TrackMan is, it's a lifelike scenario in which we will have a professional player enter a batting cage provided by OTW, and the TrackMan will track the bat swing, the bat speed of the professional baseball player, as well as the launch angle from the bat to the ball, and also the speed of the ball, along with
Exit speed as well.
Exit speed as well. There you go. And along with the TrackMan data, we will also have cameras set up all around to also track the elongation of the bats.
Yeah, this will be one of the most fruitful, when it comes to data, one of the most fruitful methods, as it will grant us quite a bit of data to work with and define parameters. In this, whenever we do take it to the TrackMan facility, we will be taking uncoated bats, bats coated with genetic coating from other companies, as well as the
resin from OTW.
Exactly, as well as the resin from OTW. This is to provide us some comparative data between all of these series and realize what is the positive or negative impact created by these resins. Exactly. Moving onward to the second method.
So another method to track the energy transferred from the ball to the bat,
suggested by Dr.
Christiana Chang. Exactly. And so she suggested that we take a bat and we hold it by its handle. We have something to hold it by its handle, and it'll be parallel to the ground, and we will drop an item of known modulus of resilience from a specified height, and we will drop it. So that will be in our parameters, and we will keep that the same. What we will be checking for is the distance that the ball travels after it hits the bat. That way we can see how much energy is absorbed by the bat versus how much energy is maintained through the ball, in which case the hardness, as
Mechanical
Mr. Perez mentioned from OTW, will be determined in terms of ball distance or ball transfer.
And once again, we'll try to get comparative data by comparing an uncoated vat with a vat with a generic coat, and then once again one with OTW's resin mix.
Exactly.
Now for the third task that we believe would complete the data that we are required to have would be an actual hardness test, a real hardness test in the resin itself. As the resin is actually a company secret by OTW for obvious reasons,
right.
We will be conducting an ASTM approved test in which we would actually conduct both micro rupture and nano rupture on this material in order to find its mechanical strength. And then we would also try this as in a composite system where we have not only the resin itself, but now incorporating the part of the wood, as the resin is only a small percentage of the wood vat.
Exactly. And even though this will not fulfill our scope, we do feel as though that it's a great starting point, and also it can lead into what other tests and research we need to conduct.
And as we conduct this test, we believe we will come across other barriers that we will need to find a way to overcome, and as well as we will get more ideas on what future tests might need to be implemented and what other research we might need to delve into in order to provide more reliable data, not only for us, but in order to benefit our client, OTW Batco. Thank you so much for watching. This has been Marco Espinosa,
David McLeod, and of course, Go Cougs.